Hi, today I want to talk to you about a concept I like to call casino code or layered cake casino code. Once upon a time, we used to use our cortex and look at street signs and all sorts of road signs to navigate from one place to another. And then the apps came along like Waze and Google Maps and whatnot. And then you just punch an address and you magically get there. And in a similar way, we start to view vibe coding or casino coding, where we punched in a prompt, like pulling a lever, and code comes out like magic. But code is not navigation. It's not just about reaching the destination. The LLM many times generates a solution. Sometimes it asks, sometimes it just generates it. It looks okay because maybe we don't understand or know or just think it's okay. It believes a certain solution is the correct one and it kind of sticks by that, even if it's not the correct one. You might need different solutions for different problems. And that comes from experience, from understanding, and it's not necessarily one size fits all. So what I want to do in this two-part series will identify and demo some of the casino code problems. So let's see, I've asked it I want to create a fast API for to-dos with a get, set, and search endpoints. And I'd like to save it to a database. Seems reasonable. So it started off by creating a CRUD file. CRUD is ambiguous. It's usually for databases, but sometimes many times for APIs. So it's already a little bit of meaningless. In this case, it's already chosen SQLAlchemy. So obviously this is the database layer, not the API layer. So it'd be nice to be called something like database layer, the file, or repository pattern, or something of that usage. However, our app is very simple, and SQLAlchemy is a beast. Choosing that for such a simple thing starting off is definitely the wrong choice. So again, it's decided to do that. It's actually doing all of those. It's creating DB execute statements, etc. And then it doesn't look so horrible, but still, we already have a commit and a refresh, and it's already on a high level of complexity. However, we didn't need this complexity. And this is an example of where an inexperienced developer would just go, keep all, this is great, love it. This is not correct at all. This is not the right solution for something simple. And then we also have database, and it's actually using SQLite. It's an overkill to use SQLAlchemy with SQLite. SQLite has its own library. You can implement everything very simply, very lightly, without all the complexity. SQLAlchemy will give you so many problems. And then we have the main. So we can see that it's actually having a to-do set request, which is one model. And we have schema here. And then to-do create, which also sit in the same place. And then that goes into the schemas and to-do read. And that builds it from ORM. So we have these models that go back and forth. We have models and schemas. It's already not a bad design per se if we're developing something high-end, but again, it lacks that context. And this is a very simple example where I just asked it to create an app. It created a lot of complexity and a lot of different schemas, and the naming convention is a little confusing. And the more we add to it, and you can see that these are very similar things as well. So we have the schema. Let's look at the models. So we basically create a to-do, which is the to-dos. That looks pretty okay. However, we can see that all of this has added a lot of complexity for a simple prompt that we might not even need. It's made a lot of choices and a lot of assumptions. And this is just a very, very simple prompt. So when you run this on bigger and more complex apps, a lot of different decisions are being made, and there's a lot of pitfalls that can happen. And I'm going to run the same thing over again, and let's see what it generates now. It's planning, it's designing. So now I'll let it run and create a new app, and you can see right away, CRUD is gone. It doesn't like CRUD anymore. It doesn't believe that there needs a service anymore. So let's look at main. Now the create to do add still. It's returning the post. Now it's a mixture of things. The list to do, the DB queries is in the main file. Now we have a get DB, but there's also a database. So there's ambiguity on what's happening with the database. So this one is a declarative base. Again, it's very persistent, as you can see. Here's an example of bias. It's very sure that it needs to use SQLAlchemy. So we're looking at main, and there's a whole bunch of things here. And then there's models. So some things have been, but you can see it's decided to make a wholly different structure in terms of like how it designed the core of the app. And this might seem like a small change, but it's very meaningful. Before we had a nice separation, the CRUD kind of made sense. The name was off. This time we don't even have that. and it's decided to do other things. And this is an example of the non-deterministic nature of exactly the same prompt generating a significantly different application. And now let's do the same thing over again, and let's try to... Okay, let's do that one. I'll send the exact same prompt. Let's see what it does for this prompt. It's again making the app there. Again, you can see it's choosing SQLite over and over again. And it's using SQLAlchemy. That's exactly the bias. These files look very similar. Schemas look similar. Main. Implementing persistence layer. Found 8 errors. And then again, I chose the not so complicated design. Now I included a README, which is not bad. Now he's explaining what he's done. Now there's a database, there's a main again, there's the schemas, a slightly different solution, similar to the last one. As what happens is once you start using and doing the same thing over and over again, it kind of saves things in cache. So you do expect some similarity, especially if you're using the same model. But again, we don't have a guarantee. These things are non-deterministic. That is part of the overall issue. I cleared all the history, and let's ask one more time. I removed the folder. Let's see what it does now. I'm going to let it run. So again, I'm going to use SQLite. It's going to make the folder. What are we getting inside the folder now? So you can see now we have CRUD again. It's not a bad pattern with this CRUD, but again, it's an overkill. And this time we kind of look at like, oh, it just added a completed flag. That's new functionality it just came up with. So now it's explaining how to run it. But again, we have the ORM. It's very insisting on using an ORM, which for a simple app, I don't think is the right tool at all. But again, someone else would just keep, and off it goes. All right, let's do one more attempt. And now I'm going to run the same thing with plan mode. This is auto, this is plan mode. And let's see what plan mode gives me in this case. Now remember, the more I've ran this quite a lot of time, now it's kind of asking me, what do you want? In the previous run, it asked me, do you want A, B, or C? Let's just go with the same mistakes it made before, but this is much better. It's asking me. It still doesn't realize that you don't necessarily need an ORM. So implement SQLAlchemy. You see, it has this bias to continuity, persistence, migration, testing and verification. It's got all of those. So let's give it a build. I'm just going to let it approve everything. So if you don't know, you would just say approve. This sounds like a really good plan, unless you really understand. And this is part of the problem with Casino Code, is that we just approve all of these things constantly, and we don't always know what it is doing. Even in planning mode, when we get a lot more insight, if you don't know how to make those right decisions, the AI might make a lot of decisions for you that are incorrect. It still doesn't make the basic problem. And I've ran this plan mode before. It didn't even ask me which database I want. And then we see that despite the planning mode and the thinking, at the end, we're getting something quite similar. Create app, database, looks similar to the previous runs. Models, created at, now there's a created at, the complete has gone away. Again, this non-deterministic nature. Schema looks pretty consistent across runs. Completed. And again, there's no CRUD, there's no database layer. There's a session maker. Again, the app, created to-do, does straight to the DB. So here we've skipped that layer, which is not necessarily, now it's creating tests in this case, which is already an improvement, but still, this is a very non-deterministic nature to build software. And again, this is a very simple, very small example of using the tool in multiple ways creates similar by different results. That's an example of how Casino Code comes into play in a very simple manner. Let it finish. Now it's going to test the to-dos. So it's creating a database, override get DB, set a model. I don't even know if this code runs. Let's see if it even runs. And then it starts the error out. So someone will start, this code doesn't even work. So not only have we generated a lot of different types of codes and a lot of different results, none of them actually are good. None of them are addressing the problem correctly. And if I've done that, and imagine the multiplication that happens when I do this over and over and over and over again, even in planning mode, we've got the file, the CRUD is gone again. So this sums up the first part. We've seen how generating a simple to-do app multiple times across runs gives various different results, makes a lot of bad decisions, and generates working code, but this is not exactly the code that should go into production systems. And we've exposed some of the simple, straightforward issues, so you need to be aware and keep in mind, and later on in follow-up videos, we will deal with how do we put rail guards and how do we ensure that what it gets produced is what is needed. So stay tuned, click subscribe, and I'll catch you in the next video.